Hello, I'm Professor Rad, and this is Precalc video 318, Finding Values of Theta. So as we're moving forward in the next several videos, we'll be looking at undoing trig functions. In other words, instead of starting out with an angle and then finding a ratio from that, we're going to start out with a ratio and find the angle. So in order to help us do that, we're going to be working through some exercises in this video to help acquaint us with the unit circle a little bit better and orienting ourselves around the unit circle so that we can find angles in specific windows more easily. So we're going to start out with an example, and I think I've got, 6 angles here. So we want to identify the quadrant that each angle is going to land in. So we want to make sure that we can navigate around the unit circle well enough that we can find the quadrant of an angle, because that's going to inform whether a trig function is positive or negative. So here's how we can do that. So for this first angle, we have alpha is 3 pi over 8. I guess 3 pi must have been really hungry if it over 8. So we're going to start out by drawing a little mini unit circle here. And what we're going to do is we're going to divide each of the quadrants up based off of the denominator. So based off of eighths here. So we have 0/8, and then over here is pi. So pi is the same as 8 pi eighths. That means that half is going to be 4 pi over eighths. And then if I add 4 pi to 8, I get 12 pi over 8. And then, if I added another 8 or another 4, that would get me up here to 16 pi over 8. Basically, what I'm doing is I'm writing pi halves in terms of eighths, 3 pi halves in terms of eighths, pi in terms of eighths, and 2 pi in terms of eighths. So everything's just in terms of eighths because that's what we have here. Now, by labeling my quadrants in this way, it gives me a little bit of a window to see where 3 pi eighths is going to land. So 3 pi over 8, the numerator 3 is smaller than 4. So 3 pi over 8 is going to land over here somewhere. So this means that alpha is going to be in quadrant 1. So this is going to be our main, strategy, our main method of attack. So let's look at beta. Beta this time is in terms of sevenths. So we're going to divide the quadrants up based off of sevenths. Now, one thing that was nice about eighths was that 8 is even, so we could evenly divide it. We can do the same thing with sevenths, although we're going to end up with some decimals. So here we have 7 pi over 7. And then what you want to do is you want to take half of 7. So half of 7 is 3.5. So that's going to go up here, 3.5 pi over 7. And then if you add that to here, that'll give you this one on the bottom, 10.5 pi over 7. So now that we've got those, we want 6 pi over 7. And so 6 is in between 3.5 and 7. So it's going to land us over here in quadrant 2. So that's the main idea. What I'm going to recommend is that you take a moment, pause the video here, and work through the remaining 4. See if you can figure out what quadrant they're in. And then when you're done, you can unpause the video and I'll have the answers on the board and we can go through them to check. So go ahead and pause here and see if you can finish these 4 remaining angles. All right, let's see how we did. So I found that gamma, which is negative 11 pi over 8, was going to land in quadrant 2. Now this one was a little bit different than the first 2 examples we went through because it was a negative angle. But all that means is we're going clockwise instead of counterclockwise. So instead of calling this a positive 8 pi over 8, because I would be going counterclockwise, I would go clockwise. And so this would be a negative 8 pi over 8. Half of that is negative 4 pi over 8. And then up here we have a negative 12 pi over 8. So negative 11 is going to be between negative 8 and negative 12. So it ended up here in quadrant 2. For delta, we had negative 3 pi over 7. So same thing, we're going to go clockwise this time. And here was my negative 7 pi over 7. Half of 7 is 3.5. So here's my negative 3.5. Since negative 3 is smaller than 3.5, I'm going to be over here in quadrant 4. This Greek letter is epsilon. So epsilon was 6 pi over 5. So I did the same thing as normal. I went in a counterclockwise direction because we had a positive angle. And 5 pi over 5 was over here where pi is. Half of that is 2.5. And 5 and 2.5 gave me 7.5. So 6 is going to be between 5 and 7.5. So that landed us in quadrant 3. And then this fun letter is xi. And so xi was negative 11 pi over 5. And so I went in the clockwise direction this time. And actually, I had to go past 2 pi because if we're counting by 5s, negative 5 pi is here. Negative 10 pi over 5 is here. So then I went to negative 12.5 pi over 5 is this over here at negative 3 pi over 2, essentially. And so ended up here in quadrant 4. So xi was in quadrant 4 for this one. So how did you do? Were you able to locate the quadrants of the angles all right? So this is our first stage, is making sure we can kind of navigate around the unit circle using the denominators basically as like an index to get us in the right spot. Now let's tie this into finding some trig values as well. So one of the things that we observed by graphing trigonometric functions is that they are periodic. So if I wanted to find what values of x is sine of x equal to 0, there are literally infinitely many places. And that's not just the case for 0, that's the case for anything that's in the range of sine. So if I said, find all the values for which sine is a half, or in this case, negative 1/2, then there are infinitely many values that will answer that question as well. So let's take a moment and look at this first example. And we're going to find all of the angles in this domain, in this interval here, from negative pi to 2 pi, so that the sine of that angle will be negative 1/2. So basically what we're doing is instead of just saying, oh, there's infinitely many answers at the end, we want to find the specific answers within a particular domain. So to help us out, we're going to look at the unit circle to go through here. So I'm going to sketch a unit circle. And it can sometimes be handy to kind of sketch the angles that you're looking at. So we're interested in going from negative pi to 2 pi. So first, let's go from 0 to negative pi. So we're going to look in this window here. Sorry, from 0 to negative pi. So we want to look at the negative angles in that interval. And then we're interested in 2 pi. So we're going to be looking at the angles in this interval. So that little diagram is going to make more sense once we go looking for the answers. But I like to map out those intervals first. Start out at 0, because that's where you're going to start measuring your negative angles and where you're going to measure your positive angles. Next, we want to graph out the places where sine of theta is equal to negative 1/2. So sine is the y value. So we want the y value to be negative 1/2. So that's going to be over here and over here. So those are the two lines, right, where our y value is going to be negative 1/2. Now these look like pi 6 to me, so I'm going to keep that in mind when I'm counting my angles. So let's draw out our pi 6 to help us as we count. All right, so to recap everything that went into this diagram, those red arrows are indicating this domain that we're going to be looking at. So we have going from 0 to negative pi, and then from 0 to 2 pi. The solid lines I've drawn are when the sine value is equal to negative 1/2. That's when the y value is negative 1/2. Looking at this, this looks like pi 6. So I've drawn in all of the pi 6 to help me to count. So those are the three pieces that make up this picture. Now I'm ready to go ahead and answer the question. So I'm going to be interested everywhere those red arrows that I drew intersect those solid lines I drew. So in the negative zone here, we have this one and this one. So this first one, that's going to be at negative pi over 6. And now I'm going to count my pi 6. So that's 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6. So I also have a negative 5 pi over 6. That's taking care of this negative track. Now I need the positive spots. So for the positive angle rather. So as I go around the top, I'm not interested in the dotted lines. I'm just interested in where that red arrow is going to intersect those solid lines that I drew. So now I'm going to count the pi 6ths again to figure out what these two angles are. So we have 1, 2, 3, 4, 5, 6 pi over 6. So this one's going to be 7 pi over 6. 8, 9, 10, 11. So we have 11 pi over 6. So that's going to be our answer to this question. All of the thetas that are in this interval, so that sine of those values is going to give me negative 1/2. This next example is going to kick it up another notch. So instead of telling us a trig value that we know, now we have, we want cosine of theta to equal cosine of negative 3 pi over 5. Oof. So here's what we're going to do. Just like we did in those previous examples where we were kind of quadranting out where all the different like pi 5ths or pi 7ths lived, we're going to do that here as well. We're going to draw out the pi 5ths because we have an angle that's pi 5ths. So let's start that out. So I'm going to draw these, I think, in green to start out. So here we have 0 pi over 5. And then here we have 5 pi over 5. So what I need to do is I need to divide this this top circle into fifths. And I know that this is 2.5. So I know that 1/5 and 2/5 will be over here, and then 3/5 and 4/5 will be over there. So I don't have to be super precise. I'm just going to use this as a guide. This is my 2.5 pi over 5. So let's say that this is 1 pi 5th, and let's say that's 2 pi 5ths, and then 3 pi 5ths and 4 pi 5ths. It's really not perfect, but it doesn't have to be. It's just a guide to count. And then here we have our 5 pi 5ths, and we'll do the same thing for the bottom half. So we've got, here's a 6 and a 7, an 8 and a 9, and that brings us up to 10. So each of these lines, I'm going to count as a pi 5th. Notice that I'm not counting the y-axis, right? Because that was a 2.5, so I'm not going to count that one. So I've divided this up into pi 5ths, just as I use like these dotted lines to help guide me as pi 6ths up there. Next, let's take a look at the interval that we're looking at. So we're looking at from 0 to pi. So we're looking at this interval here from 0 to pi. So we're only interested really in half of the angles that we drew. And lastly, let's diagram where this angle is going to land us. So this is cosine of negative 3 pi over 5. So negative 3 pi over 5 is going to land us 1, 2, 3. It's going to land us here. All right, so this is our diagram. Just to recap what went into this diagram, these green lines are fifths or pi 5ths, and that's based on the fact that this was a pi 5th. This is going to help us count pi 5ths as we go around the circle. The red arrow is indicating where we're looking for answers. So we're looking for answers from 0 to pi. And this blue dot is indicating the angle that we're looking at here for the cosine. Now, in order to find which of these is going to have the same cosine as this angle, we need to think about what cosine is. So remember that cosine is going to give you the x value on a unit circle. So I have this point here at -3 pi fifths, and I need to reflect it into either the second or the first quadrant so that I find an angle that has the same x value. So in this case, that means I'm going to be reflecting it up here. This angle is going to have the same x value as down here. So this angle was 1, 2, 3 pi over 5. So theta is going to have to be 3 pi over 5. And that's it for this one. So there's nowhere else, especially because our window was so small. We were looking at between 0 and pi. So we had a smaller window to look at. So we were just finding this solution here. All right, let's take a look at a couple of additional examples. Alrighty, so for our next example, we want to find all phi in the interval from -3 pi halves to 3 pi halves, so that cosecant of phi is equal to cosecant of 2 pi over 3. So let's draw this one out. So here's my unit circle. And let's take a moment and let's draw out the pi thirds. So I'm going to do pi thirds because the angle that we have is in terms of pi thirds. So pi thirds are, here's 1 pi third, 2 pi third, 3 pi thirds, 4 pi thirds, 5 pi thirds, 6 pi thirds. And as we go around, we'll be counting on those green lines. So the green lines are representing pi thirds because that's the angle we have. Now let's indicate the interval that we're interested in. So we're interested in from -3 pi over 2 to +3 pi over 2. So I'm going to go from 0 to -3 pi over 2 first. So that's going to bring me up to here. And then I'm interested in 0 to +3 pi over 2. So that's going to bring me there. So they're both like 3/4 of the circle in both directions. Okay, so that's my indicator here. And then lastly, let's graph 2 pi over 3 because that's the cosecant value we're interested in. So cosecant of 2 pi over 3 is 1, 2 is over here. So this is where 2 pi over 3 is going to bring us. All right, so now we have to figure out which of the green lines we're interested in hitting. So cosecant is the reciprocal of sine, and sine is based on the y value of the point. So that means that cosecant is going to be based on the y value of the point. So we want to find all of the other places of these green lines that will have the same y value as this point here. So if I were to reflect this down, it has the same x value, but now has the negative y value. So it's not this one down here, and it's not down here either, because those are both negative. So the only other line where it's going to have the same y value is over here, because both of these have the same positive y. So that means as I follow those red lines that I drew, as I go in the negative direction, I'm going to be interested in this point here. And in the positive direction, I'm going to be interested in this point and this point. And as I follow the line, it stops here and there's nowhere else where it hits. So we're going to get 1, 2, 3 solutions to this problem. So in the negative direction, as I count, this would be -1, 2, 3, 4. So we have -4 pi over 3. And in the positive direction, we have 1 and 2. So we have pi over 3 and 2 pi over 3. Now, this last one's not really surprising because that's what was given to us, and it just happened to be in our interval, so we're going to include it. But then these other two are the other two values that we would need to include. All right, and let's take a look at our last example. So here we want to find all theta from negative pi to pi, so that cotangent of theta is the same as cotangent of 15 pi over 8. So once again, we're going to draw our unit circle. We're going to mark out eighths, so we know where the eighths are. We're going to indicate using that like red arrow where negative pi and positive pi are going to be. And then we're going to graph 15 pi over 8. So take a moment, see if you can draw the little sketch of the unit circle to indicate those three things. And then on pause and compare with what I've drawn. Alrighty, so let's see how we did. So this is my unit circle here. And I cut it up into 8 pieces. So this time, well, really 16 pieces. This time, both the X and the Y axis ended up being eighths. So if I'm counting, I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. From here to the other side of the X axis is negative pi, and here's my positive pi. And then to graph the 15 pi over 8, I just counted until I got to my 15th one, and there's my 15 pi over 8. So that's the first stage, is getting all that given information into a picture. Now we need to think about cotangent and how that relates to the graph. So cotangent is the ratio of X to Y. So what this means is we need to find all of the places where the ratio of X to Y is the same. This is different from this example and the previous one where we had cosine, because cosecant is going to be just 1 over Y on a unit circle. So it only depended on Y, it didn't really matter what the X value was. Here, it does matter, this ratio here. So remember that tangent and cotangent are positive in the first and fourth quadrants, or sorry, first and third, and they're negative in the second and the fourth because the X and Y's have different signs. So we're going to have to bear that in mind here, because here we have our 15 pi over 8, and its corresponding spot that will have the same ratio of the X and Y is going to be this point over here. So if we think about what we've got here, we've got a long X and a short Y, and that matches. We have a long X value here, and we have a short Y value, so short distance up. So that sort of ratio is bearing in mind here. And we had a positive X over a negative Y, which will result in a negative. Here we have a negative X over a positive Y, which will result in a negative. So these are the two lines that are going to have the same cotangent value. So I'm going to highlight those because those are now the ones that I'm interested in. And if I look at the red line, it intersects here, no more in the negative, and it intersects once up here. So as I go through the negative swing of angle, it's going to be a negative 1 pi over 8. So we have negative pi over 8. And as I go through the positive swing, it's hitting here. So I'm going to count 1, 2, 3, 4, 5, 6, 7. So it's hitting at 7 pi over 8. So this is our set of values for theta that will have the same cotangent value as 15 pi over 8. All right, so that's where we're going to stop this video here. This is just kind of a preview of some tools and techniques we'll be needing to find inverse trig functions in the future. So that's what we'll be looking at in the next video. We'll figure out how can you find the inverse of a trig function, and this will come in handy as we go through that process. So hopefully we've got some new tools in our toolkit to move forward, and yeah, I'll see you in the next video. Until then, have a magnificent day. Bye for now.